Hi guys, welcome to your third mini lecture in the Composites and Hybrid Materials series. I'm George Riding. For those of you who don't know, I am part of the Furniture First Year team, and I'm going to be introducing you to this process today. And also I'll have a little special guest with Randy, who will give you an example of the process as well. So for those of you who don't know, vacuum bag moulding is a flexible process for forming fibre reinforced polymers, polymer laminates into a wide range of shapes and sizes. So you can see the carbon fibre part there on the right, quite small, but it can be used right up to larger parts such as canoes and wind turbine blades. It's an extension of the wet layup process which Emily spoke about in the previous video, and the extension being that it's placed in a vacuum bag and the air being sucked from the bag compresses the material over the mould. We can have a quick look at that process now. So obviously the material you are wishing to form is placed over the mould. This is then covered with two materials. The first is a peel ply, which is which you can see on the right there. This is a woven Dacron cloth which assists with the demoulding and surface finish of the product. When cured, at the end of the process, the peel ply is removed and the surface will be free of any harmful sharp edges and spurs. This is then covered as well as with a breather fabric. So this is a relatively thick fabric and one that allows the air to filter through during the process, and also it absorbs any excess resin as well. So that can be seen there on the bottom right. So once these materials are laid up, the mould and the materials are then placed in a vacuum bag. These bags are typically made from a polypropylene that is modified to resist heat, to resist high temperatures. The film has an elastic nature which allows for high formability and resistance to puncturing during the process. Once everything is inside the bag is then sealed around the edges with a special sealing tape and connected up to a vacuum pump, which will then obviously suck all the air out. Suckle the air out between the bag and the mould. Therefore, the material is compressed over the mould. This is all done under 1 bar of pressure, so relatively standard process. Vacuum bagging is often undertaken in an oven, and that's to assist with the curing of the resin and obviously the material laminate. Once cured, the vacuum pump is turned off and disconnected. The vacuum bag, breather fabric and peel ply are removed and thrown away. The part can then be removed from the mould. And just to give you an idea of what the process looks like in person, this is a lovely image of the process there. You can see how much the vacuum bag flexes and compresses into the mould to form the shapes. And we've got a really nice example of the process being used by Randy, who's on one of my great friends, and he shows this process, how this process is used to make a canoe. So I'll pass you over to Randy now, and he can talk you through that.
Hi, this is Randy Zajac, Technical Advisor at Goujon Brothers Incorporated. Today we're going to take a brief look at the vacuum bag process while laying up a fiberglass canoe hull. Before we get started, here's a quick look at the elements used in this particular layup. Mold release, gel coat, fiberglass, peel ply, breather fabric, vacuum bag sealant, and vacuum bag film. To wet out the fiberglass, we used West System 105 resin mixed with 206 hardener. The gel coat was a mixture of West System 105 resin and 205 hardener thickened with 406 filler. Here we are cutting our vacuum bag film to length. Ideally, the film is about 20% larger than the mold to allow enough room for contours without bridging. To start, we found the center of the film and stuck it down to the center of the mold with a vacuum sealant tape. We worked the film from the center out, making pleats in the bag every few inches. The number and size of pleats is determined by the complexity of the part's shape. The vacuum bag film at the ends of the mold was sealed to itself and then to the mold. Once the bag is completely sealed to the mold, we mark the position for the vacuum cup and cut a piece of the film away for air to travel through. We put vacuum sealant tape on the suction cup so it will stay sealed if vacuum is lost for a short time. Suction cup placement depends on part geometry. Typically you don't want to put it on what will become the finished part, but off to the side. It was not an issue for our canoe here. A trap is put in line with the vacuum tubing to catch any excess resin before it goes into the pump. The air is evacuated from under the bag and a vacuum is generated. As the bag is evacuated, it is important to position it to avoid bridging in any tighter spots. If you have any leaks, fix them with vacuum sealant tape. Once the part is under vacuum, don't remove the bag until the part cures. After the part is cured, remove the vacuum bag, breather fabric, and peel ply and pull it from the mold.
So thank you to Randy for that really insightful video into the process and showing how it can be used on sort of a larger scale. From the video you should be able to see a lot of advantages and disadvantages from the video. So a lot of some of the advantages are being that it's a really flexible process and can be used to manufacture really large parts such as wind turbine blades. Using one bar of pressure allows for a low tooling cost, and obviously because you're using air as the sort of compressing force, you get a really uniform force across the whole mold, and that allows for some really nice details that can be seen in the mold to come through into the final material, the cured material. The high fibre content laminates can usually be achieved with this process rather than the hand layup process. But there are some disadvantages to this process. So there's a higher level of skill required than the hand layup process. There's obviously a lot of waste generated with the bag, the peel ply and the breather and any other materials such as mold release films that will just be discarded after use. And it actually only provides a good surface finish on the tool side. The surface finish on the bag side is less good, so that's obviously good you need to be aware of. I have put some more links here for you to have a look at if you want to explore this more. So there's two websites there that have are interesting to read through. So you've got Conventive Composites and Materials Today to sort of sum up this process really nicely. And then there's two other YouTube videos. Sadly, Randy will not be in those YouTube videos. I know you're all disappointed by that, but again, they are interesting examples of how this process is used on a much more smaller scale, and will be good to watch. So thank you for listening to today. I hope you found it interesting, and yeah, good luck, and hope you enjoy the rest of the videos in this series.